Hey guys, today is day 2 of the properties of exponents. Today we're going to talk about properties involving quotients or division. So before we start, let's do it a little bit bigger here. So if I had 4 to the 5th power, 4 to the 5th power is like saying 4 times 4 times 4 times 4 times 4. And if I wanted to divide that by 4 to the 3rd power, okay, that's 4 times 4 times 4. Okay, if we looked at it like we were canceling out, we could cancel out the 4s, the second set of 4s, and the third set of 4s. Then we would just be left with 4 to the 2nd power. Okay, so if you notice the pattern here, the exponent 5 with the base 4 and the exponent 3 with the base 4, all we have to do is subtract the two. So take the exponent of the numerator minus the exponent of the denominator. So this would be 4 to the, if we canceled them out, 4 to the 2nd power. So to divide powers with the same base, we just subtract the exponents. So that's our new rule. Okay, if we had variables, we would, in this case, the base is a. So the base is the same for the numerator and denominator. And then we have m minus the n. Okay, so we just would subtract the two. All right, so looking at some examples here, let's get this out of here. Okay, number 1, we've got the same base. We've got 2 to the 10th and 2 to the 4th. So 2 would be to the 10 minus 4 would be 2 to the 6th. Okay, number 2, the base is -3, 7 minus 2. And if we, let's go back to number 1. If we actually evaluate it, we would get 64 because we have just the number. Number 2, -3 would be to the 7 minus 3 power, so it would be to the 4th power, which would be equal to a positive 81. Again, it's very important when you use your calculator to put that -3 in parentheses before you find the exponent. All right, number 3. So we're multiplying the numerator. So we're going to go straight across. We're using the property that we learned last class. So if we multiply, we have the same base. You actually add the exponents. So that would be 4 plus 2 is 6. So we'd have 5 to the 6th, then divided by 5 to the 3rd. Now, because we have the same bases, we subtract, and we end up with 5 to the 6th minus 3 is 5 to the 3rd. And then we evaluate, and we get 125. Okay, so this one looks a little weird, but it's, you just think of this as another fraction, just put it over 1, go straight across, and you're going to get x to the 6th divided by x to the 4th. So then our rule applies. We have the same base, we subtract the exponents, we end up with x squared. All right, 6 to the 11th divided by 6 to the 9th would just be 6 squared, which would be 36. And -4 is the base here. 9 minus 7 is 2. Again, a negative times a negative is a positive, so we would just get 16. Okay, so this might be good for you to pause the video and practice the next 3 on your own. Okay, I'll continue on. So when we continue on, this would be 9 to the 8th power divided by 9 to the 6th. So we get 9 squared. 9 squared is 81. Okay, put this over 1, I end up with y to the 8th divided by y to the 5th. When I subtract the exponents, I get y cubed, y to the 3rd. And now this one, okay, notice the coefficient down at the bottom is just 1, all right? So with the number, the coefficients, you're still dividing. 2 divided by 1 is just 2. X to the 5th divided by x to the 3rd is going to be x to the 2nd power. So there's your answer there. Okay, so the next property that we're going to talk about is the power of a quotient property. So what that means is if you have a quotient or a fraction, and I'll do it big here again, all right, 2 to the 5th to the 3rd power, it's just like saying 2 to the 5th times 2 to the 5th times 2 to the 5th. Now how fractions work, you multiply the numerator straight across, so you'd get 2 to the 3rd divided by 5 to the 3rd power, 5 cubed. Okay, so when you have a power of a quotient property, you're actually going to find the power of each, the numerator and denominator. Okay, so this one would be 2 to the 3rd divided by 5 to the 3rd. And this would be a to the m divided by b to the m. Okay, so looking at our example, okay, let me erase this. Oops, there we go. Okay, so we've got 3/2. So applying this property, we would have 3 to the 3rd divided by 2 to the 3rd, which would be evaluating 3 to the third is 27, 2 to the third is 8 rather. Okay, so we get 27/8. Okay, and then it's 27. Kind of messy there. All right, now number 2, we would just take the numerator and cube it. So x to the third divided by y to the third, and that would be your final answer. All right, when you have a negative, you're going to pick either the numerator or denominator. Usually we pick the one with a number, so -7, we're going to square it, and then we have x squared. -7, when we evaluate it, would be 49, so 49x squared. Okay, number 4, we take our a to the fourth divided by b to the fourth. Okay, number 5, we're going to get -5 to the third divided by y to the third, so we're going to have a -125 divided by y to the third. Okay, number 6, now we're going to apply power to a power, so x squared would be we multiply x to the fourth. Okay, and let's just break this one down a little so you can see it. So we're actually taking the numerator, x squared, and we're squaring it, and then we're taking the denominator, 4y, and we're squaring that. Okay, x squared would be x to the fourth. And now the denominator, we would have 4 squared, which is 16y squared. Okay. All right, now number 7, this one would become 5 would be to the third power, x would be to the 6th power, and the denominator, 5 would be to the third power, y would be to the third power. Okay, 5 to the third divided by 5 to the third would cancel out, okay, and we'd get x to the 6th divided by y to the third. Okay, number 8, a would be to the 10th power, because power to a power, divided by b to the 5th, and we're multiplying that by 1 over 2a squared. So when I go straight across, I've got a to the 10th divided by 2a squared b to the 5th. Okay, so now when we go straight across, we're just going to, we only want to have one occurrence of the variable, so a to the 10th divided by a squared is going to be a to the 8th, and then in the denominator we have 2b to the 5th. Okay. Number 9, okay, we've got our 2 to the 5th, s to the 5th, our 3 would be to the 5th, our t would be to the 5th, and we're multiplying that by t divided by 16. 2 to the 5th is 32, 32 s to the 5th t, okay, is then going to be divided by 3 to the 5th is 243, okay, t would be to the 5th, and then we're going to be multiplying it by 16. Okay, I just went straight across here. Okay, and I set it up like this because your 32 and your 16, you can actually cancel this out a little. It makes it a little bit easier. And then when we divide, we end up with 2, s would be to the 5th, and t divided by t to the 5th would be t to the 1 minus 5 is -4, so that's going to stay down on the bottom, t to the 4th. Okay, that was a little bit harder. Number 9 might not make sense until we do our next class where we talk a lot more about negative exponents. Okay, so the back of this page is really set up for just simplifying, okay? But if it's just numbers, I want you to get an answer. So I'll do some of them together. 5 to the 4th would give you 625. Okay, this would be a -3 cubed, which would be a -27. Okay, then we've got 9 minus 7 is 2, so -3 would be squared. We get 9. Okay, notice for number 4, the negative is out front. The base here is 3, so the negative stays out front, kind of like a -1, and then we'd have 3 to the 4th power. So you'd evaluate 3 to the 4th, and you would get 81, and then take the negative of it, so it's -81. Okay, number 5, we're going to go straight across here, and we're going to get 2 to the 12th. When we add, divided by 2 to the 10th. When we subtract the 2, because we're dividing, we would get 2 squared, which is 4. And 6 would be 1 to the 4th divided by 2 to the 4th, so we'd end up with 1 over 16. 17, we're going to take the -5 and square it, and 4 would be squared, so we're going to get 25/16. This would be negative 2 to the third over 3 to the third. So we're going to get a negative 8 over 27. Okay, 1 to the fourth over 3 to the fourth times 3 to the fifth. Well, 1 to the fourth is just going to be 1. So when we multiply through, we've got 3 to the fourth divided by 3 to the fifth divided by 3 to the fourth. When we subtract our exponents, we end up with just 3 to the 1 power 3. Okay, number 10, we've got 4 to the ninth times, and we've got a negative 1 to the fifth and a 4 to the fifth. Okay, negative 1 to the fifth is just going to be a negative 1. So we're left with a negative 1 times 4 to the ninth divided by 4 to the fifth would be 4 to the fourth. So when we evaluate that, we end up with negative 256. Okay, this one would become z to the 8th divided by z to the 7th. We just subtract. 8 minus 7 is going to be 1, so we end up with just a z to the first power, or z. Number 12, negative 1 would be to the 5th power divided by x to the 5th. Evaluate negative 1 to the 5th would be negative 1, so we end up with a negative 1 over x to the 5th. All right, 13, when we do 13, we've got our negative 4 is going to be cubed, and x is going to be cubed. Okay, when we do that, we evaluate negative 4 cubed is negative 64 over x to the third. Okay, 14, we've got a negative a, so we can say negative a to the 4th power. Now a negative to a positive exponent, a negative to an even exponent is going to be positive. So then we've got that divided by b to the 4th. So we can just write this as a to the 4th divided by b to the 4th. All right, 15, we end up with 4 cubed c cubed over d to the second to the cubed would be d to the 6th. And when we multiply, when we evaluate, we get 64 c cubed divided by d to the 6th. All right, this one, 16, a would be to the 35th power, 2 would be to the 5th power, b would be to the 5th. When we evaluate 2 to the 5th, we get 32, so 32b to the 5th. All right, number 17, x squared squared would be x to the 4th, and then we would have 3 squared y to the 6th, so it would be x to the 4th divided by 9y to the 6th. Okay, and then number 18, 3 would be to the 3rd power, x would be 5 times 3 is 15, and then we would get 7 to the 3rd power, and y would be to the 6th power. So we end up with 27 x to the 15th divided by 343 y to the 6th. Okay, and then the last three get a little more complicated. Okay, so this is going to be 3 squared x to the 6th over 2 squared y squared, and that's going to be multiplied by 1 over x squared. So we go straight across and evaluate. We get 9x to the 6th divided by 4 x squared y squared, and just move the x over here. Okay, I like to put them in alphabetical order. Now I line up my x to the 6th divided by x squared would be x to the 4th power, and in the denominator we'd have 4y squared. All right, number 20, 2 would be to the 3rd power, x would be to the 9th power, okay, and then y would be to the 3rd power. That's our first step, and then we multiply that by 1 over 6x to the 3rd. So 2 to the 3rd is going to be 8x to the 9th, and we'll move the coefficient out front, and we get 6x to the 3rd, y to the 3rd. So now we can simplify 8/6 and we get 4/3, and x to the 9th divided by x to the 3rd would be x to the 6th, and then on the bottom we've got our y to the 3rd. And finally, number 21, we have negative 5 squared divided by x squared times 2 squared, and that would be x to the 8th divided by y to the 6th. So we'll evaluate the negative 5 squared and get 25 over x squared times 4 x to the 8th divided by y to the 6th. We go straight across, we get 100 x to the 8th divided by x squared y to the 6th, and then final step, we divide x to the 8th divided by x squared is x to the 6th, and that would be divided by y to the 6th. Okay, so there you go. I know there's a lot there. You might want to look at the key and go through it slowly.